Hello everyone, my name is Sully Devrix, and this is my AppArmor and HTTPS presentation. Here's a quick overview of what this presentation will be talking about. Lab environment overview, AppArmor technical overview, AppArmor how it works, AppArmor status and configuration, AppArmor hardening recommendations, HTTPS technical overview, HTTP versus HTTPS in secure counterpart, HTTPS TLS operation, HTTPS on Windows, IIS overview, IIS HTTPS hardening recommendations, HTTPS on Linux Apache overview, Apache HTTPS hardening recommendations, lab validation using Nmap, how this applies to our lab, and our references and works cited page. Lab environment overview. This lab environment is designed to simulate a small enterprise network using both Windows and Linux servers. The purpose is to practice implementing host-based security controls and securing network communications. On the Linux side, we focus on AppArmor and IP tables, while on the Windows side, we use IIS Windows Firewall and HTTPS. By configuring and validating these controls, we gain hands-on experience with defense in depth, where multiple security layers work together to reduce risk. AppArmor technical overview. AppArmor is a Linux security model, or LSM, that provides mandatory access control at the application level. Instead of focusing on users, AppArmor restricts what individual programs are allowed to do. It uses path-based profiles that defines which files, directories, capabilities, and network resources an application can access. This approach makes AppArmor easier to understand and manage compared to some other Mac systems, especially in lab and small enterprise environments. AppArmor, how it works. AppArmor works by loading security profiles into the Linux kernel. When an application runs, the kernel checks every action it attempts, such as reading a file or opening a network connection, against its assigned profile. If the action is allowed, it proceeds normally. If not, AppArmor either logs the violation or blocks it entirely, depending on the mode. Enforce mode actively prevents unauthorized behavior, while complain mode is used for testing and tuning profiles. AppArmor status and configuration. Administrators can manage and verify AppArmor using built-in command line tools. The most important command for our lab is sudo aa-status, which displays whether AppArmor is running and shows the number of loaded profiles, including how many are in enforce or complain mode. This command is critical for the server check assignment because it proves AppArmor is enabling and protecting applications. Configuration files for profiles are typically stored in the etc AppArmor.d. AppArmor hardening recommendations. Hardening AppArmor involves several best practices. First, all production services should be run in enforce mode rather than complain mode. Second, profiles should follow the principle of least privilege, granting applications access only to required resources. Third, unused or default profiles should be reviewed and removed if unnecessary. Together, these steps significantly reduce the impact of compromised applications by limiting what attackers can access. HTTPS technical overview. HTTPS, or Hypertext Transfer Protocol Secure, is the secure version of HTTP and is used to protect data transmitted between clients and servers. It uses TLS to provide encryption, authentication, and data integrity. HTTPS is essential for preventing eavesdropping, credential theft, and data manipulation. The default port for HTTPS is 443, which is one of the key indicators we verify in our labs using network scanning tools. HTTP versus HTTPS. Insecure counterpart. HTTP transmits data in plain text over port 80, making it vulnerable to packet sniffing and man-in-the-middle attacks. HTTPS addresses these weaknesses by encrypting traffic and validating server identity through certificates. Modern browsers actively warn users when HTTP is used, emphasizing its insecurity. Understanding this comparison reinforces why HTTPS should always be enabled, even in internal lab environments. HTTPS TLS operation. TLS secures HTTPS connections through a process called the TLS handshake. During this handshake, the server presents a digital certificate to prove its identity. Encryption keys are then negotiated, and a secure session is established. Once complete, all data exchanged is encrypted. This process ensures confidentiality, integrity, and authentication between the client and the server. HTTPS on Windows IIS overview. On Windows servers, HTTPS is implemented using Internet Information Services, or IIS. IIS allows administrators to bind SSL or TLS certificates to websites and manage encrypted traffic. In our lab, we use a self-signed certificate, which is sufficient for testing and validation purposes. IIS is widely used in enterprise environments, making it an important platform to understand. IIS HTTPS hardening recommendations. Hardening IIS involves disabling outdated SSL and TLS versions, such as TLS 1.0. HTTPS should be enforced by redirecting HTTP traffic to port 443. Additionally, unnecessary IIS features and models should be removed to reduce attack surface. These steps help ensure IIS operates securely even if exposed to a network. HTTPS on Linux, Apache overview. On the Linux server, HTTPS is configured using the Apache web server. Apache supports SSL through the mod SSL module and allows administrators to define encryption protocols, certificates, and security headers. Like IIS, Apache can use self-signed certificates in lab environments. Apache's flexibility makes it one of the most commonly deployed web servers in the world. Apache HTTPS hardening recommendations. To harden Apache HTTPS, outdated protocols such as SSL v2 and SSL v3 should be disabled. File and directory permissions should be restricted so Apache only accesses required resources. Enabling security headers like HSTS helps enforce HTTPS connections. These practices help protect the server even if vulnerabilities exist in the application. Lab validation using Nmap. After configuring HTTPS and security controls, we validate our setup using Nmap or ZenMap. By scanning the servers, we can confirm that port 443 is open and that unnecessary ports are closed. This provides external verification that our configurations are working as intended and that secure services are properly exposed. How this applies to our lab. This lab demonstrates how layered security controls work together in real environments. AppArmor restricts application behavior, firewalls control network traffic, and HTTPS secures data in transit. By configuring and validating these technologies, we gain practical experience that directly applies to real-world system administration and cybersecurity roles. Here is the references we're excited page. The references listed on this slide include official documentation from Ubuntu, Apache, Microsoft, and other trusted security sources. These materials were used to guide both the research and the lab configurations. Using authoritative references ensures our security practices align with industry standards. That is the presentation. Thank you for watching.